Okay, so now we're going to learn about the volume of cones and spheres. We don't need to know, for right now, the surface area of cones and spheres, just the volume, so that's kind of nice. All right, so what we can understand and know that when you have three cones and they have the same height and radius as a cylinder, three of these cones will fit into the cylinder. Three of the contents of these cones will fit into one cylinder. So because of that, and all they have the same radius and the same height, because of that, 1/3 of the volume of the cylinder will equal the volume of the cone, okay? Or you could say that, remember now that the formula for the volume of a cylinder is the area of the base times the height. Remember that for the volume of any cylinder, any prism, including a cylinder, is the area of the base times the height. Well, the base is a circle, so the area of a circle is pi r squared times the height of the prism. Well, for a cone, it's going to be 1/3 of all that. So the formula for the area for the volume of a cone is 1/3 pi r squared h. Okay, let's do an example. Here we have a cone. It's 2.5 centimeters high, and the radius is 1.9. If you want, if it helps you to go ahead and say r equals that, that might help you. So you set up your formula. Volume of a cone is 1/3 pi r squared h. You have 1/3, you have pi, your r is 1.9, so you put 1.9 squared, and then your height is 2.5 times 2.5. Notice we're all multiplying, no adding. Adding is when you do surface area. So all these are going to be multiplied together. When you punch all that into your calculator, you should get 9.45 centimeters cubed, because it's volume, three-dimensional, or you would get about 3 pi. Okay. Another example. Supposing you have the volume of a cone, if the volume of a cone is about 94 feet cubed, and the diameter is 6, what is the height of the cone? Okay, so we're going at it from the other way. We're giving you the volume this time. So the volume is about 94, and so we write down our formula first, and then we plug in, just like we usually do, but this time we actually can plug in the volume, the actual volume, which is 94. And then equals 1/3 we copy down, the pi we copy down. The radius, well, if the diameter is 6, your radius is 3. And it's always good to go ahead and write that down so you have it right there. And that'll be 3 squared, and then times h, which we don't know, so we leave that unknown. So we can go ahead and do all this on our calculator, and we get about 9.4 times h equals 94. So if you would just have had that as an equation back at the beginning of the year, well, you put your line down, and you say, what do you do to solve the equation? Well, this is being multiplied, 9.4 times height. So to undo it, we divide by 9.4 both sides. That reduces to 1, so we're left with 1 times h, or h. So our height is going to equal 94 divided by 9.4, and that's 10. So my height is 10. Okay? All right, so now we're going to talk about the sphere. Okay, it turns out when you have a sphere and you fit it into a cylinder with the same height as the height of the sphere and the same radius as the radius of the sphere, then the sphere actually takes up 2/3 of the cylinder. Okay, pretty cool. So there's like 1/3 of space in there, so to speak. Okay, so what we're going to do, what we see then is the volume of the cylinder is pi r squared h, just like before, but we're going to take 2/3 of that. Okay, so in this particular case, let's see, no, we're just going to do a generic case. All right, so the height, though, we realize the height of the cylinder is really this r plus that r. It's really 2r, or the diameter, okay, but it's 2r. So we plug in place of h, we put 2r. So we have 2, and then put the 2 in the front. We got pi, and then r cubed. Well, the sphere is 2/3 of that. Maybe I can show it over here. So the sphere is 2/3 of the 2 pi r cubed. And that's kind of what I did here. So I can do, so then that just becomes 2 times 2 is 4. So that's really going to be just 4/3 pi r cubed. And that turns out to be the volume of a sphere. Okay, let's do some problems with it, and then we'll be done. Okay, so supposing you have the bottom sphere of a snowman has a diameter of 3 feet. Find the volume of that sphere. Okay, so I drew it out, and I put down, showed that the diameter is 3 feet. I wrote down my formula first, volume of a sphere, 4/3 pi r cubed. Okay, then I wrote down 4/3 and pi, we know those numbers. The r now, if my diameter is 3 feet, my r is 1.5 feet, you could say. So my R is 1.5, and then I have to cube it. So you cube it, what I did here, I think, and what might be helpful, is just cube that first, then multiply it by 3.14, then multiply it by 4, and then press enter, and then divide the whole thing by 3. That might be easier than doing the 4/3, depending upon the calculator that you have. And then, so you simply get that answer. Okay, now this one, number 2, is a little bit trickier. All right, you have tennis balls. It got kind of erased, but you have tennis balls in a container, right? And the diameter of the tennis balls is 2.5 inches. And they're sold in cans that look like this. You've seen them with three in a stack. Okay, what is the volume of the space not occupied by the tennis balls? Sorry, that got erased. Okay, so what's the volume of the space that isn't occupied by tennis balls in that particular container? So we've got to do some subtracting, don't we? All right, basically we're going to do the volume of the cylinder minus the volume of the spheres times 3, because I have 3 tennis balls in there, equals the volume of the space that's left over. Okay, well I know the volume of a cylinder is pi r squared h. I know the volume of a sphere is 4/3 pi r cubed, but I got 3 of them, so I'm multiplying it by 3. Okay, so that just means it's a matter of just plugging in the numbers. I know my d is 2.5, so if my d is 2.5, half of 2.5 is 1 1/4. So my r is 1.25. Then to get my height, I've got to think about it now. If my diameter is 2.5, that means from here to here is 2.5. Well, that means, and this, I'll go up here. Then this, from here to here, for this, the lower tennis ball, that's 2.5. The next tennis ball, that's 2.5. And this is 2.5. So I add all those together, or multiply them by 3, and I get 7.5. So the height of my sphere is 7.5. The height of my cylinder is 7.5. Then I subtract 3 times all this with the sphere, and all I need for the sphere is the r, and that was 1.25. Okay, then I worked all this out, I got 36.8. When I worked this out, you can cancel the 3's, right? They reduce each other. So you just really got 4 times that thing cubed. When you work it all out, you got 24.5. And then when you subtracted it, you got 12.3 inches cubed is the volume of the space left inside. All right, and that's it. We'll work on more problems and get some good experience with it.